All right, guys, what's up? Mr. Custis here. Third week back for in-person kiddos. Virtual kiddos kind of doing the same thing, right, as we have been. Looking forward to another good week. Not a lot of time left. We're winding down. This week we're talking about Pythagorean Theorem. All right, Pythagorean Theorem. Nerd alert, I've actually used this right in real life, not in math class, right? It is possible. Let's talk about why we might use Pythagorean theorem. All right. So it can be used to test whether a triangle is a right triangle. Right? That's something we're going to do today. It can be used to find missing side lengths in right triangles, something we're going to do today. And it's used frequently in construction. I used it when I built the play set for my kiddos. Engineering, computer systems, and natural sciences. All right. So today we're going to use Pythagorean theorem to find missing side lengths in right triangles, right, like we set up here a second ago, and to test whether triangles are right triangles. Okay. So we can find out if a triangle, if we know there's 3 side lengths, all right, we can find out if a triangle has that 90-degree angle. All right. You might, maybe you've talked about in math in the past, right? That 90-degree angle is really important. Because it's like the strongest angle, right? That's why we build all of our buildings with right angles, because it's the strongest, right? It's going to hold up the best and not collapse, right? Obviously, you don't want your home to collapse, so we try to make sure all of our walls, foundation, all those things are right angles to make it real sturdy and strong. All right, so here is the Pythagorean theorem. Here's a right triangle, right? We can see the 90-degree angles right here. So we have A, B, and C. All right, and it is important. These two are interchangeable, but C always has to be opposite of this right angle. Right, it's what we call the hypotenuse. Side C is called the hypotenuse. So then sides A and B, we call these the legs. All right, so we have leg A, leg B, and the hypotenuse. And if this was changed and this was leg B and this was leg A, that'd be okay. We just have to make sure that C is in the right spot. All right. So the hypotenuse, that side C, is always opposite the right angle, right? It's not touching it. We would say it's not adjacent, right? Adjacent means it's right next to. So it's not adjacent to the hypotenuse. It's opposite the hypotenuse, right? The only side that 90-degree angle does not touch is the hypotenuse, right? It touches both the legs. The hypotenuse is always the longest side, okay? If it's opposite the 90-degree angle, it is the longest side, okay? You may have noticed in the past, right? If you have a triangle, the side opposite the biggest angle is always the biggest side. Okay, so the 90-degree angle is always going to be the biggest, right? We know that the 3 angles have to add up to 180, right? We learned that back in the fall. So we know that C has to be the longest side, right? So let's get into a little bit of practice. Let's look what it actually looks like to use Pythagorean theorem. All right, so here's our first Khan Academy assignment. All right. So the first thing we've got to look at, right, before we start plugging this into a calculator, start solving this, is what are we missing? Okay. So I see my right angle right here. All right. So there we go. So I know this is a leg, and this must be C that we're missing this time. All right. So this can be A, this can be B, right? These are interchangeable. You could have put A and B separately, wouldn't matter. Okay. But I know, right, we're going to do A squared plus B squared to get C squared. Okay, so this time we're looking at 12 squared plus 16 squared. All right, and that's going to be C squared. All right, so let's figure out what that is. Let's use our calculator. And again, I'm going to suggest, like I have been to all of my students, Desmo's scientific calculator, all right? We get to testing, this is what you got to use. So it's a good idea to go ahead and start using it. So we have 12 squared plus 16 squared. So 400, all right? 12 squared plus 16 squared is 400. So I'm going to come back here. I'm going to put 400 equals C squared. All right, great. We're almost there. All right. So C squared, or X in this case, right? It says X is the side length. But look, we have C squared. We don't have C yet. We don't know this distance yet. I just know what this distance times itself is. Okay, so here's a new button on the calculator that we haven't used yet to find x here. All right, I need to undo this. I need to do c, okay, not c squared. I need this to be a c. So how do we undo, how do we undo a square? Well, to undo a square, right, the opposite operation is that square root. All right, so I'm going to take the square root of c squared and the square root of 400. All right, and the square root of 400. So back to the calculator. All right, now I need to do a square root. So the square root of 400 is 20. All right, square root of 400 is 20. So there it is. X is 20. All right, so there's our first one. Let's do another one here. All right, important, right? Before we start getting into this, we got to make sure that we have the right A, B, C here. So I know, right, it's not touching the 90-degree angle. This must be the hypotenuse. It must be C. All right, so we have A and B here. So we have 2 squared, right? We'll call this A this time, plus 10 squared. And that's going to be equal to our C squared. All right. So here's another way that might speed up this process a little bit. If I went ahead and said the square root of this, the square root of this, now I know, right, the square root of 2 squared plus 10 squared is equal to our C. So maybe this will speed things up a little bit. Let's try this out. So let's do square root, and we had 2 squared plus, it was 10, right? 10 squared. I'm not sure that's all in here. Maybe I need some parentheses to make sure this is all in the... Oh, it's not gonna work. Try a shortcut. It's not gonna work. All right, so we'll do 2 squared plus 10 squared, 104. Now the square root of 104. Ooh, that's not fun. 10.198039303. So that is irrational, right? This is not a perfect square, so I know this is an irrational number. That's rounded here, right? It would continue to go on forever. So square root of 104, or this, right? Square root of 104, all right? So here they've just left it in that square root form, totally fine, instead of rounding. All right, now again, this one's going to be slightly different, right? Because this time they've given us the hypotenuse. All right, so we've got to solve for a leg this time. All right, so this one's going to be a little different. We got A, B, C. So now what? X squared, or you could type in A squared here. It wouldn't really matter. Plus the 4 squared is equal to my 5 squared. All right, so if I'm solving for the x squared, I need to get rid of this 4 squared first, right? I want the x by itself. So x squared equals 5 squared minus the 4 squared, right? I just subtracted 4 squared from here and from here. All right, so 5 squared minus 4 squared. Let's go ahead and solve that. And maybe you don't even need a calculator for this one. Maybe you do. 5 squared minus 4 squared is 9. All right, this is 25 minus 16. So we have 9. And we're not quite done, remember? X squared is 9, but not x yet, right? So x is the square root of 9. The square root of 9, right? Number times itself, that makes 9. It's 3. All right, 3 times 3 is 9. So the square root of 9 is 3. All right, again, right, just like the last one, this is the hypotenuse. This is our C over here. So this is A and B. So we have x squared plus 3 squared equals 8 squared. All right, so again, subtract the 3x from here and from here. So we're going to have x squared equals 8 squared minus 3 squared. Let's go ahead and do that. 8 squared minus 3 squared is 55. And I know that's not a perfect square, so it's probably just going to be the square root of 55 here, right? They're not putting in the irrational numbers, they're just leaving it as a square root. It's kind of nice. All right, one more. All right, this time both the side lengths that are touching that right angle are given to us. So this is back to the original kind, right? They've given us both the legs, and we're solving for the hypotenuse. So you can put x squared here or c squared here. So 9 squared plus 12 squared. 9 squared plus 12 squared is 225. It looks like a perfect square to me. Let's check it out. Square root of 225 is 15. All right, it's 15. All right. So this is the first Khan Academy assignment that you'll all be working on. So hopefully that helps with that one. Now let's look at the second one. Which side lengths form a right triangle? So they've given us all 3 side lengths, and we're seeing if it is or is not a right triangle. All right. So 4, 7, and 9. Let's go ahead and test that one out first. All right. 4, 7, and 9. So we have, which one's the hypotenuse? Hopefully you remember we said the hypotenuse is always the longest side. Okay, so we're going to do 4 squared plus 7 squared and see if that's equal to 9 squared. Okay, so 4 squared plus 7 squared, 65. Is that equal to 9 squared? Hopefully you know. But look, right, 9 squared is 81. So those are not the same. I know that's not a right triangle. All right, let's try the next one. 5, 12, 13. So, you know what I'm going to do this time? I'm just going to replace these. 5, 12. That's 169. And 13 squared is also 169. So there's a right triangle. Now, don't jump the gun and say, okay, well, that's the right triangle. I'm done. Because it says choose all answers that apply. Okay, all the answers that apply. So we also need to check the 20, 22, 24. All right. So we have 20, 22, and 24, not the same. So there's just the one answer this time. All right, 4, 8, 12, same thing as last time, all right? 4, 8, and 12. 8, 4, 12, not the same, okay? 2, square root of 5, and 3. And important to know here, right? Square root of 5 is a little less than 3. So 3 is the hypotenuse. It looks like they have them here in order, legs and then the hypotenuse last. So 2 square root of 5. So the square root of 5 squared, right, is just 5. And then it was 3, right? All right, so that one is a right triangle. All right, we get 9 on both of those. And then 2, 2, and the square root of 8. So 2 is already there. 2. And then we have the square root of 8. So that's also a right triangle, right? So this time we have 2, right? It's a good thing we checked all of them. 5, 6, 7. So that one's not. 6, 8, and 10. 6, 8, and 10. Yep, that one is, all right? Both sides equal 100. And then we have 9, 9, and 18. That one's not, all right? So we just got 1 this time. All right, last one here. We'll get 4 out of 4. Call it a day. 5, 6, and square root of 30. Got rid of my square. 5, 6, and square root of 30. That one's not. 2.5, square root of 18, and 5. So what would the square root of 18 be? Let's just double check. It's between 4 and 5, right? It's got to be less than the square root of 25, right? Square root of 25 is 5. So I know this is a leg. All right, I'm just double checking here. They still do have them in order. So 2.5 square root of 18 and 5. Oops. 2.5 square root of 18. Oh, I already know this one isn't because it says 24.25, not 25. All right, so close, super close. Maybe it's like 88, 89 degrees, but not 90. All right, not a 90-degree angle. So I guess this one's got to be right. Square root of 2, 2, and square root of 6. So square root of 2, 2, and that's 6. So I know the square root of 6 squared is also going to be 6, right? All right. So it's this one. All right. So that's it for this week. You got the 2Con Academy. You got your quizzes. Let us know how we can help. All right. Looking forward to seeing you all again in class. Having a great time. Please come to our virtual office hours, virtual classes when you're not at school and get that help you need. Hopefully this video helps. Proud of you guys. You're doing a great job. We're almost there, right? Just a few more weeks. We've got to do this Pythagorean Theorem. 2 weeks of this, 2 weeks of exponent rules. And then that's all the new content for this year, right? So looking forward to finishing up and having a great summer. But I'm really having a great time back here in school. All right. Thanks, guys. Have a good week. Let us know how we can help.